Many of us have purchased the commercial electric AC voltage detector and after using it for a while have decided that it's really just too sensitive for any detailed troubleshooting work because it alarms when it's anywhere near, like within 6 inches or so, of an electric circuit, and that's not really what you need for troubleshooting. What I'm going to show you in this video is a way to desensitize the tester so that it can be used for troubleshooting. One thing I should point out is that the original tester is sensitive down to about 50 volts. After this modification, the tester will probably not respond to 50 volts, but will certainly respond to the 120 volts and higher that we normally have in household circuits. Taking the tester apart is just as if you were going to change the batteries. Open the battery compartment, and once you remove the batteries, just pull the circuit board right out of the slot that it's in the case. This is very easy to do. You may have to pull out slightly on the rubber buttons so that they can clear the circuit board with no problems. Once you've pulled the circuit board out of the tester, this is what it looks like on the bottom side where the batteries were. If you turn it over, then you see what it looks like on the other side, except in this picture, of course, you'll see the resistor that I've added to the circuit that wasn't there originally. This is a picture that shows what the little circuit is that we're going to modify. There are several circuits on this board, but this is the one that needs to be changed to affect the sensitivity. It's just 2 resistors in series, which gives you a total resistance of 44 megohms to ground. What we're going to do is to add another resistor in parallel to the bottom of these 2 resistors, to shunt it in effect, in order to reduce the total amount of resistance. At my local Fry's Electronics, I found the 7.5 megohm resistors were available, and I've also verified that the Radio Shack in my town has 10 megohm resistors, so either one of those would be fine. I believe the 10 megohm might be preferred since it will give slightly higher sensitivity. On the circuit board we see a place where it looks like a 5-pin connector could be inserted, probably for testing purposes, and for our purposes it's important to notice that the middle of those 5 holes is a ground connection, so we're going to use that place for the ground side of our added resistor, and then you just need to connect the other side of the resistor to the junction of R3 and R4. Notice that the 2 resistors at this point are already tied together, so if you manage to short them out with the resistor lead that you're adding, that doesn't change the circuit and will be fine. You'll see that I've added some insulation that I stripped from another piece of wire onto the resistor leads to make sure that they don't short out any of the components or traces on the circuit board, and I also added a piece of electrical tape under the resistor for that purpose. Putting the circuit board back into the tester is just the reverse of how you took it out. You just push it back into the slot in the case. You do probably need to pull out again on the rubber buttons as the circuit board slides by them so that the board doesn't get hung up on those. So in conclusion, here's a demonstration of what my circuit tester behaved like after I made this modification. You'll see that putting the tester probe into the neutral side of the outlet does not alarm, which it certainly would have done before this change, and getting the probe close to the hot side of the outlet does cause it to alarm, so that's exactly the kind of behavior that we wanted.